Hello students, so we'll move on with the next problem that was given to you in those questions. So that is the second one. Okay, so this is a given data to you wherein arrival time is given, burst time is given, as well as priority is given. So arrival time is nothing but when the job had come into the system, okay, whereas burst time is nothing but how much time that particular job or process takes to execute or complete, whereas priority is nothing but each of the jobs will be given some priority. Based on that, jobs will be executed. Okay, suppose if there are two jobs, okay, so both the jobs will be given some priority number. Based on that priority number, CPU is selected. That is, based on the priority number, CPU can be given to any of those processes. Okay, so in this question, what is given to you, what they are saying here is larger priority number is having higher priority. Okay, so sometimes this data will be given to in the question. If they're not given, then you have to write as assume smaller number will be having higher priority. Okay, smaller priority number will be having higher priority, but in this case in the question they have mentioned that is larger priority number is having that particular process is having higher priority. Okay, so first thing here, you remember preemptive means what? You can stop in between. Once you give the CPU to particular process, it is possible for you to take the CPU away from that process. So first you should remember this, so don't get confused. So any algorithm that will be asked to you, first thing you have to remember whether it is preemptive or not. You must know the meaning. Preemptive means you can stop in between, whereas non-preemptive is once you give the CPU to a process, you're allowing that process to complete fully. Okay, so now we'll come here. Preemptive followed by priority. Priority means based on the priority you are giving the processes to the CPU. Okay, so we'll draw the Gantt chart here. So please don't get confused. Try to understand properly. So here, Gantt chart. Okay. So arrival time is given to you. Arrival time is given to you, that is 0. So at the 0th millisecond, how many process do you have? You have only one process, that is J1. Okay, here J1 is nothing but job 1. We can also call it as process. So whatever they have given in the question, same thing you have to write in the Gantt chart. Okay, so previous problems we had used as P1, P2. Here they have given as J1. J1 is representing a job. That is nothing but when it is executing, that is called as a process. Okay, so at arrival time 0, you have only one process, that is J1. So we will give J1 to CPU. Okay, so J1 takes how much millisecond to complete? 6 milliseconds to complete. But this is preemptive. So whenever preemptive means you cannot allow the job to complete fully, you have to stop and check at the next arrival point. What is the next arrival time? That is 3. At 3, so you see here, you have two processes. You have jobs J2 and J3. Both are coming in at 3. Okay, at any point of time, if you have this kind of situation, okay, so now in this case, both have come in at same time 3, but here the priority is different, that is 2 and 6. But if the priority is also were same, then what you have to do here is whichever has come first, that is in the order which is first, that you have to consider. Now in this case we won't be having that problem because priorities are different. Okay, same thing can occur in SJ, that is your preemptive SRTF, that is your SRTF also. Think here, both the jobs have come in at 3 and the burst time also might be same for both 5. That time you will be in a confusion as which one you have to select. That time what you have to do, you have to use first come first serve, that is in the order whichever is first, that you have to take and give it to CPU. Okay, so we'll come back here. So you have J1 you have given to CPU. Now CPU will be executing, but since this is preemptive, you are stopping in at the next arrival point. At next arrival point, you have two processes, that is, or two jobs, that is J1 and J2. So write the status here, J1, J2, J3. So at arrival time 3, you have three process or jobs which has come into the system. Okay, so we'll write down their status. J1 actually takes 6 milliseconds to complete, but out of that 6, 3 you have executed. So 3 you are writing. Okay, but since this is priority, you have to consider the priorities also. So within the bracket you can write the priority number. Okay, if this was SRTF, then only you're writing the burst time. But this is priority scheduling algorithm. Even the priority need to be considered. And J2. J2 takes, what is the burst time? 5. And what is the priority? 2. And J3, burst time is 3 and priority is 6. So in this particular problem, they have told higher priority number. Okay, this is priority number. Higher priority number will be having the highest priority. So according to this, what will happen now? J3 is having the highest priority number. So what you have to do, you have to preempt or you have to stop J1 here and give the control of CPU to J3. Okay, so now J3 has to execute. So J1 has preempted or stopped here. So J3 will be executing. J3 takes how much millisecond to complete? 3 millisecond to complete. So if you add 3 for this, actually it will go up to 6. But what is happening at 5, you have another process coming in, so you cannot go up to 6, but you have to stop at 5 and check. At 5, if you are checking what is the status of your system, you have process J1, J2, J3 and J4 coming in at 5 millisecond. J1, what is the status? Burst time remaining is 3, priority is 4. J2, burst time is 5, priority is 2. J3, here it was 3 burst time, but out of 3 how much you have executed? 3 to 4 and 4 to 5. So 2 is executed. So how much is remaining now? 1 with the priority 6. And J4, the burst time is 5 and the priority is 3. So which process is having the highest priority here in this case is J3. So what you're doing, you are allowing J3 to execute. So how many more time it requires? It requires only 1 more millisecond. So up to 6 it will go. Now J3 is completed. Now what is the status at 6? We have J1 with burst time 3 and priority 4. J2 with burst time 5 and priority 2. J3 with burst time 1. J3 is completed, right? We have J4 with priority 5 and burst time 3. Out of this, which is having the highest priority? 3, that is J1 is having the highest priority. So you're allowing J1. Now in this case again you don't require to stop and check. Why? Because all the process has come in. The last process has come in at 5. You already crossed that fifth time limit. Okay, time slot. So any more not required to stop and check. So what you're doing, you're allowing J1 to complete all the 3 seconds. So 6 plus 3 means it will go up to 9. At 9, what is the status? You have J2 5 remaining and priority 2. J4 burst time is 5 and priority is correct, right? Yeah, both are having the burst time as 5. J2 burst, yes, J4 also burst time is 5. Okay. So in this now, who is having the highest priority? That is J4. So you're allowing J4 to execute. So it will go up to 14 and last remaining is only J2. Again that is correct, right? Last remaining is J2 5. So it will go up to 19. Just verify. 10, 16, 19, yes, bus time is same here also you got. So this is how you have to draw the Gantt chart. So whatever is written here is only for your reference. Okay, in the exam if you want to write in pencil, in the exam they are going to check this point 0, 3, 5, 6, this point they are going to check. Now how you are going to calculate the waiting time? Waiting time, how you are calculating for J1. J1 came in at 0 millisecond, got the CPU at 0 millisecond, so 0 minus 0. Again, do you have J1? Yes, we have J1 over here. So what is happening? J1 has executed till 3 and it has stopped, and once again it got at 6. So plus 6 minus 3. So it is how much? 6 minus 3. 3 is a waiting time. Similarly, J2. J2 came in at 3 and got at 14. So 14 minus 3, 11 millisecond. Similarly, J3 came in at 3, got at 3. So 3 minus 3, that is 0 millisecond. Next J4 you have. J4 came in at 5, got at 9. So 9 minus 5. So average waiting time is 3 plus 11 plus 0 plus 4 divided by 4, that is